Hello everyone. How are you? Do you have my voice? Hello. Hello everyone. Yeah. Okay, nice. Good morning. Hope everything is well with you. Hi, Amina. How are you? Actually, today I want to talk about the keypads, different types of keypads. And we will have a program or coding for working with the keypad in CodeVision. We will write the code in CodeVision and also we will run it, we will execute it in a simulation circumstance, simulation environment of Proteus. But what is a keypad? Actually, keypads used in different projects. For example, they can be used as a calculator, as a keypad of the calculator, or password lock, or also they can used in different types of projects which require to receive information as input. The different types of keypads would be, for example, 4 by 5. Different types of keypads are existing related to our request. Here you can see, let me to turn the pointer, turn on the pointer. Okay. In this slide, you can see two different types of keypads, a 3 by 4. This type is including 3 columns and 4 rows, and the 4 by 4, which is including 4 columns, 1, 2, 3, 4, and 4 rows. However, other different types are existing related to our project or our requirements. Actually, why we are using keypads? In some of the projects, it's so necessary for a microcontroller to receive information from user side, okay? So, meaning that, for example, at Mega 16 or 32, which is including 32 input-output pins, why at Mega 32 or 16 is including 32 input-output? Because it is including 4 ports. Each of ports is including 8 pins. 8 times 4 would be equal 32. Then it's including 32 input-output pins. And if you want to connect a lot of keys as inputs to it, then a lot of microcontroller pins are occupied, and they will be busy. So when our input keys are too high, for example, about a calculator, we should use another method or piece so that fewer pins are occupied. For example, about 4 by 4 keypad, how many keys are including in 4 by 4 keypad? As you see here, this is a 4 by 4 keypad. It is including 16 keys, okay? Each of these keys are suppose that are independent from each other. Then if we want to, instead of 16, instead of 4 by 4 keypads, suppose that we are using 16 ordinary keys, okay? Then in this case, for interfacing these 16 keys with microcontroller, we need 16 pins of microcontroller. Then as you see, for connecting 16 ordinary keys with microcontroller, we actually occupying 16 pins of microcontroller. Then they would be busy, and what does it mean? It means that the microcontroller can't be used for other tasks. We can't interface other devices to that because most of the pins of microcontroller actually are busy. But about 4x4 keypad, when we are using keypad form of 16 keys, we only need 8 pins of microcontroller, or about this type of keypad, 4x3 keypad. You know that it is including 12 keys, and if we want to not use a keypad and we want to use ordinary keys, we should use the 12 keys, which would be interfaced with the microcontroller. Then it would be required to occupy 12 pins of microcontroller with our keys. But when we are using keypad, actually, the structure of the topology of a keypad is, in the case, in a matrix structure, and in which, for example, in 3x4 keypad, for interfacing with the microcontroller only, we need less number of pins, meaning that we need only 7 pins of microcontroller to interface with that, and about 4x4 keypad, we need only 8 pins of micro instead of 16 pins in ordinary 16 keys. Am I clear? Then we can understand that why we are using keypad instead of ordinary keys, because it gives an opportunity to use less number of pins for interfacing with the same number of keys with microcontroller. Any question? Am I clear? Do you understand? Any question? Okay. Okay, nice. Actually, here in this image, you can see a 4x4 keypad. This image shows the schematic of how to connect the 4x4 keypad, and by pressing a button, the key is connected between row and column, allowing the current flowing between the pins of rows and columns. So, for example, this is the inside of keypad, the connections related to the keys. As you see, it is including 16 keys, but they're connected to each other, as shown is in the figure. In this figure, you see that all of the keys from one side are connected to each other in the rows. You see that, for example, in this row and this row, all of the keys from left side are connected to each other, and also you see that I called, for example, this row as R1, this row R2, R3, R4, and also the keys from the other side, as you see, they are connected to each other in the columns. For example, in this column, from right side, switch 1, 4, 7, and star are connected to each other. This is column 1, column 2, column 3, and column 4. So when we're pressing one of the switches, for example, switch 1, then the current between row 1 and column 1 is flowing, and then we can say that the current flow between the pins of this is a pins related to the row of keypad, and this is a pin related to the column of the keypad. Then And these are actually connected to the microcontroller. I will talk about them in next slides. And the current, by pressing this switch, actually we create a connection between row and the column, which is related to this switch. But how we can determine which switch is pressed? To determine that which switch or key has been pressed, if we connect R1, R2, R3, R4, you see that row 1, row 2, row 3, row 4 are called as R1, R2, R3, R4, and column 1, 2, 3, 4 are called as C1, C2, C3, and C4. If we connect R1, R2, R3, R4, good, listen to me. If I connect all of these rows of my keypad to positive 1, meaning that what? I configure them as input and activate their pull-up resistors, okay? And C1, C2, C3, and C4 also configured as output, and their initial state determined as high voltage or connected to 5 volt, okay? At first step. Then R1, R2, R3, R4 has high voltage, and also C1, C2, C4, C3, C4 also are high voltage. Then I start to have C1 up to C2 pins write a code to create 0 respectively for each of these columns, meaning that C1 up to C4 pins are 0 respectively. At first C1 becomes 0, then C2 becomes 0, then C3 becomes 0, and then C4 becomes 0, meaning that by having each of these columns at a given time which are zeroed, then we want to check the situation of, we want to read the situation of or data of rows. So at first step, we said that what we can do. At first step, all of the rows and the columns are configured with high voltage. The rows are configured as input, and their pull-up resistor is activated. And the columns also are configured as output, and the initial value is high voltage. Then one by one, each of these columns initial value becomes 0, okay? At first C1, then C2, then C3, then C4. In this situation, we will have two states. If no key is pressed, okay, if no key is pressed, suppose that we didn't press any key. R1, R2, R3, R4 pins are 1 because they are connected to high voltage, pull-up resistor is activated. And the C1 up to C4 are 0 respectively, okay? But once a key is pressed, one of the rows, for example, suppose that we press this key. When we press a key, one of the rows becomes 0. Why? Because by considering that which column is 0, we can recognize the pressed key, because we said that at any given time, the columns are respectively become 0. Their states, their values become 0. So by pressing a key, The row and the column of that key, which is at any given time is becomes 0, cause that the row related to that become 0. Okay, so since at any given moment only one pins of the columns is 0 and the rest rest are 1, if more than one key is pressed, micro only accept one of them. So then what we can understand, all of the rows at first state have high voltage, all of the columns have high voltage, but we start to make each of the columns 0 respectively at first C1, C2, C3, C4, and by pressing one of the keys, when we didn't press any key, we have high voltage in the rows and the columns are zeroed respectively, but when we press one of the keys, the rows related to the that key become 0. And it is why because at any given time one of the columns has 0 value, and then we can understand that which key is pressed. Okay, now we want to talk about the keypad interfacing with ATmega 16 or ATmega 32 microcontroller. At first, okay, nice. We can have a break. After 5 or 6 minutes, again, we can join to class. Thank you. Okay, hello again. Sorry for a long time break. Do you have my voice? Okay, is it clear? Okay, nice. Now suppose that we want to interface at Mega 16 or 32 with keypad. Which kind of keypad we're supposing we want to interface our microcontroller with 4x4 keypad. At first, we want to use Code Wizard. Okay, now I want, after explaining about the situation of the pins or ports, I will open the Code Vision and we'll talk about it. However, I'm sure that you have sufficient information from previous session about Code Wizard. At first, we open Code Vision, then we say OK to using Code Wizard, and then set the frequency of a clock on 1 megahertz, and I said that why we make such a changes. Then we set A ports, for example, A ports. You can use, for example, B ports. In this coding, I want to use A ports for interfacing keypad pins with microcontroller. Then set A port pins, first 4 bits or first 4 pins of port A, pin 0, 1, 2, 3 as output, and then connect to the columns of keypads. Okay. Then also other pins of port A, meaning that pin 4 up to 7 for other pins are configured as input and activate pull-up register for them and connect to the rows of keypad. Then what does it mean? It means that we want to interface this keypad with a microcontroller. We want to interface it with, for example, port A pins. First bit or first pins of port A are configured as output and connected to the are configured as are configured as output, and they are connected to the columns. We configure the first 4 bits of port A as output, and we connect them to the columns of keypad, and the 4 other bits of or 4 other pins of port A are configured as input and activated pull-up register and connect to rows of keypad. To do that, and then we need also LCD. Why? Because we want to see that which key is pressed. Okay. Then we use port C of microcontroller for interfacing LCD. However, you have sufficient information about interfacing LCD with microcontroller. So for having port A, 4 first bits or 4 first pins, which are connected to the columns as output, we need to write logic 1 for that bits or pins. You see that in DDRA register, I wrote for all of them logic 1. Also, I said that 4 valuable bits or 4 other bits, bit 4, 5, 6, 7, which are connected to the rows, are configured as input and their pull-up register activated. However, we can't activate pull-up register by using DDR register. To do that, we should use port A register. So only DDR-A register is used for configuring as output or input. Then 4 first bits are configured as output and are connected to the columns of keypad, and 4 other bits and valuable bits are configured as input and are connected to the rows of keypads. Then, when we write the code related to the situation of the bits, we use DDRA equals 0x. 4 zeros in hex number is x, and 4 ones is shown as f. Now we want to activate pull-up register, and we want to have initial value of 1 for all of the columns, because I said that at first all of these columns has initial value which is high, then respectively we makes them 0 respectively, and also all of the rows has high voltage, or they have activated pull-up resistor. So you see that in port A register, all of the bits have the value equal logic 1. Why? Because we said that the output pins which are connected to the columns has high voltage, and also the input pins are connected to the pull-up resistor activated. You see that all of the bits or all of the pins initial state is equal 1, and it is determined by port register. We had actually talked about it in previous sessions when we were talking about the output and input ports. So in next step, after configuring their situation initial state for input and output pins of port A, we said that one by one, each of these columns are set to be 0 or becomes 0 respectively. At first, I want to set this pin or bit as 0. Then we will have these 4 bits 1, 1, 1, and 0. So this hex number is called equal E. We said that 1, 1, 1, 1 in hex number is called which number? For converting this binary number for 1, 1, 1, 1 to hex number, we should write it as which value in hex number? Very nice. Thank you, Vassam. Thank you very much. Yes. So because we said that one by one, each of the bits is going to be 0. At first, I start from bit 0, this bit. I make it 0, then it would be equal E. So then I make it 1, but in this step, make bit 1 as 0. Then we will have 1, 1, 1, 0, 1, and this is called DN hex number. So again, I make it 1, but this time make this bit 3, bit 2 equal to 0. You see that 1, 0, 1, 1, and it is called B. And the last bit, meaning that bit 3, which is configured as output, in DDR register is set to be 0, and then we will have 0, 1, 1, 1, as you see here, and it is called 7. Now, by having this information, we know that bit 0 is connected to C1, bit 1 is connected to C2, bit 2 is connected to C3, and the bit 4 is connected to C4. We want to write the code related to the keypad operation. So we said that we want to use, for example, at Mega 16 or 32. Both of them are the same. You understand that when we are using at Mega 32 only, it's required in a code vision. We choose at Mega 32. And when we are using at Mega 16, only required to choose at Mega 16 because their features are the same as explained in first session. So we said that for seeing that which key is pressed, we need to use which device. For showing us which key is pressed, we use which device? Very nice, thank you. Yes, we use LCD. So as a previous session, I talked about it. You should enable LCD in left hand in code wizard. Then these two preprocessors are added by our choosing in code wizard. Then we start to write our program. I said that at first we configure the port A pins. First 4 bits are configured as output. First 4 bits are configured as output, and the other bits are configured, or valuable bits are configured as input. Then we write 0, logic 0 for input pins, and we write logic 1 for output pins. And then if we want to write a code in a hex number, DDRA is equal 0x0F. So I wrote it again here. And also we said that about input pins, pull-up resistor is activated, and also about output pins, initial value is equal a high or high voltage or equal 1. So you see that port A is equal 0x F in first step. Now let's go to next step. I will discuss about these parts after talking about scanning of LCD and showing it or printing the pressed key in LCD. I said that at first for actually operating a keypad or executing keypad, we need to scan key of keypad, meaning that because the columns are becoming 0 at any given time, then we need to scan the keys to understand that which key is pressed. So we said that at first we make first bit which is connected to column 1 as 0. And we called it in hex number as E. No, we don't call, actually in hex number it is called as E. So port A is equal. At first I configured port A as this one, 0xFF. But because at any given time they are becoming 0 and respectively, then I make them each of the bits as 0 equal to 0, and then read the pin related to each of keys. Okay, port A is equal 0xFE. I'm starting from the first bit making 0. Then we will have port A equals 0xFE. YF, because we didn't change the values related to 4 valuable bits related to input pins. Only I'm changing the first bit of the register, which is related to output pins. So port A is equal 0xFE, semicolon. If pin A 4 equals 0, return 7. If pin A, what we mean with pin A register? Do you remember? What is the meaning of pin A register? We said that we want to scan the keys of keypad. And to do that, we need to read the state of the registers, the data of pins. To do that, we need to use pin register, which is used for reading data. So if pin A 4 equals 0, return 7. If pin A 5 equals 0, return 4. If pin A 6 equals 0, return 1. If pin A 7 equals 0, return 10. I will talk about these values. These are related the number of the keys. Actually, I use them. Then again, I'm going to next one, meaning that this one. Bit 1 equals 0 and other bits are logic 1. Then port A equals 0xFD. Again, the same thing that I did in previous step. If pin A 4 equals 0, return 8. If pin A 5 equals 0, return 5, and so on. What does it mean? It means that, for example, make the column 1 0, okay, at first step. Then read the data of this row, read the data of this one, read the data of this one, and this one too. For checking that, when C1 is 0, we want to check that which of these keys are on. We want to know that, for example, R1 is 0, R2 is 0, R3 is 0, or R4 is 0. Because by pressing the key, we said that the column and row are connected to each other. And because we set it bit 0, which is connected to C1, we set it bit 0 to logic 0, and it is connected to C1. Then C1, all of C1 keys has connected to logic 0. But by pressing the key, each of these keys, we can understand that which connection is correct or which row is connected to our first column. If this key is connected, then row 1 actually is connected to C1. If this key is connected, then row 2, or the value, for example, I think it is 4. Yes, 1, 2, 3, 4. 4 key is pressed. If this key is pressed, then R3 is connected to C1 and it has low value. So by using these codes, we are actually meaning that if pin A4 equals 0, return 7. What does it mean? It means that, for example, we want to consider that if when C1 is equal 0, if this row value is 0, then return what? This character. It is multiple character or star character. Or for example, again, we are in first step. C1 is 0. Read R3, okay? If it is equal 0, then return what? This is 7 here. The key number is 7. 1, 2, 3, 4, 5, 6, 7. It's not clear. You can't see, but it is 7. Then return 7. Actually, we are doing the same thing here. Again, if pin A for other step, when second column is 0, second column is 0. Again, check each of these rows when, for example, rows are connected to which pin? Pin 4, 5, 6, 7. One by one, we check these pins value. Pin 4, 5, 6, 7, which are connected to the rows. And in the next step, we try for hex number B, meaning that this bit, which is connected to C3, is going to be 0. And then by having this column equal 0, we again read the register by pin register, the value of bit 4, 5, 6, 7, which are connected to R1, R2, R3, R4. And if, for example, these rows equal 0, it means that the code should return us 3. This is 3 key. If this is 0, it should return us 6. If this is 0, it should return us 9, and so on. Let me to go to CodeVision. I want to talk about the code in CodeVision, because when I'm talking here, it would be somehow ambiguous for you. And please let me talk about this point, and then I'll go to my coding in CodeVision and simulation environment, because here talking about the different part of code is difficult, because I don't have devices related to coding and also simulation, and then you can't understand what's exactly happening. Here again, I use another user-defined function as this one, but this is related to showing the pressed key in LCD. If key 1, we said that, for example, return 1. If key equal 1, LCD puts F1. We want to show when, it means that when we press key 1, LCD, please show us 1 value on the screen. If key 2 is pressed, meaning that, for example, we said that return 2. If the key 2 is pressed, please type or please print 2 in LCD screen for us. Okay. Okay, do you have the window sharing? Okay. At first, we said that we should create new file, new project. Do you want to use Code Wizard? Yes. We said that we don't make changes in this step about chip type because we are using Atmega type, and then we press OK. Okay, we said that if we should check here if the clock is 8, we should change it to 1. I explained about it. The type of Atmega is changed by these columns. Different types of Atmegas are shown here. I want to use Atmega 16 and then don't make any changes. Here, we said that we have option related to the ports for configuring them as input and output. We said that we want to interface keypad with which port. However, you can use any type of port, port B, port C, port A. But we said that we want to code or interface it with which port? We are using which port? Please open your microphone because I can't go there.
Say, Professor.
We are using port
A.
Okay, nice, thank you. Then we press port A. We said that which bits of port A are configured as input and which of them are configured as output. Do you remember? Which bits or pins of port A are configured as output, which are connected to the columns of keypad? We said that first 4 bits. We said that first 4 bits are configured as what? Bit 0, 1, 2, 3 are configured as what?
Output.
Input or output?
Output hocam.
Very nice. Thank you. Yes. Sorry, it's not working.
Hocam, I think there's a menu minimize.
No, my mouse is not working. A moment, sorry. Let me open it. Okay, again, I want to start. Yes. Okay, we said that we choose port A. We want to interface it with our keypad. First four bits, bit 0, 1, 2, 3, 3 are configured as output. We can easily configure it as output. And the other 4 bits are configured as input. About output, at first step, we said that we configured their initial value as 1, and about inputs, we activate their pull-up resistors. Okay? So, after doing that, we said that we need to use LCD, alphanumeric LCD. Then we don't make changes about port B, C, D because we only want to configure port A with microcontroller. We defined 4 switch bits. We configured 4 valuable bits as input. Pull-up resistor is activated, and about output pins, they have high voltage in first step. Then we need alphanumeric LCD. We activated. We said that we are using which type of LCD? 16 by 2 LCD. We don't make change about controller type because we interface port A with keypad, then we can't interface it with LCD. Now I want to choose port C for interfacing LCD with our microcontroller. Then port A is interfaced with what? Keypad. Port C is interfaced with LCD. And I don't make changes about the connections of pins of port with LCD's pins. So in this step, I choose generate. Okay, you see that I want to go to this step. We configured port A first bits as output and 4 valuable bits as input. When we are configuring a bit as output, we use logic 1. You see that first bits are configured as output. Bit 2, bit 3, bit 0 are configured as output. They have logic 1. These codes are generated by Code Wizard. However, we know that how we can configure a bit as or can configure a port as input or output by using DDR register. As I explained before, we can use this code for configuring port bits as input or output, but you see that it is too long, and it's possible to make mistakes when you're writing this type of code. And the type of the code that I teach you for making or configuring bits of a port as input or output is so easier than this one. But Code Wizard is using this type of coding for generating the codes for configuring bits of port as input or output. You see that, for example, bit 7 is input, bit 6 is input, bit 5 is input, because we determined in port option port A first 4 bits as input, as you see here, bit 0, as output, bit 0 is output, bit 1 output, bit 2 output, bit 3 output, and for valuable bits as input. You see that bit 4, 5, 6, 7 are as input. So do we need port B or not? No. Do we see port C? We enabled the alphanumeric LCD and we did some changes here. Then it is the code related to initializing LCD is created by Code Wizard. In this step, it's not required to make changes in the program. I want to save it and then I will make my changes. Desktop. Project key. I'm sure that you have studied about previous sessions about the creating files when we are using Code Wizard or when we are not using Code Wizard. Then I don't want to explain about these steps. We said that we should generate 3 files. Yes. Okay, we said that we can raise the comments. We are using port A because we want to interface it with our microcontroller, and we configured it in Code Wizard as input and output. Some of the bits as input, some of the bits as output. So we don't erase this code because we need it. However, sorry, a moment. Okay. If we want to erase this code, then we should write the code related to configuring the bits as input and output. You know that we made some changes in Code Wizard, and we configured the pins of this port as input and output. If we erase this one, we should write the code related to configuring port A first bits as output and value bits as input. To do that, we should write which code? DDRA equal with what? 0x 0f. Am I right? This code actually is equal with what? With this code, which is generated by CodeWizard. Okay? But because this code is generated by CodeWizard, we don't want to erase it. Okay? Then you see that also port A, all of the bits initial value is equal 1. The input bits have pull-up resistor activated, P, you see that. And the other first bits, which are configured as output here, has initial value equal 1. You see that, this one. Then this is command. I can erase it, but I want to have this code, which is actually by using which register, port A register, and writing which value for hex number, we can generate the same code. Amina, please cooperate. Very nice. Thank you very much. Yes. Instead of these too long code, which is generated by CodeWizard, we can write only, for example, 0x double f. Okay? Both of them are the same. But the code is generated by CodeWizard, and I don't want to make changes about it. Okay. Port C is configured is enabled. We enabled LCD in port C by using port C, and we initialized it. You see that the code related to initializing of LCD is generated by CodeWizard. Also, we can erase this part. And we said that it is better to not erase the connections because we are using them in our simulation and also experimental results. Now, I want to generate it to make sure that I didn't erase an important section, or for example curly braces, parentheses, or a semicolon in my code, and you see that there isn't any error. So what was my code? It was in my desktop. Project key. Pro. Okay, there was a mistake here because I put the codes that I'm writing in code vision in Pro. And no problem. I choose code for Proteus and I choose Pro for my coding. Okay. I need what? Microcontroller at Mega. Today my laptop is hanged. At Mega 16. Double click. We need what? We need keypad. Keypad. Yes, there are different types of keypad here. This is 6 by 4 keypad. It is including 6 column and 4 rows. We don't need this one. Another keypad is 3 column and 4 rows. Also, we don't need this type. Yes, this type is 4 by 4 keypad and it is suitable for us. By double click on that, it comes to our library here. Also, we need what? LCD. For LCD, yes, very nice. We said that it's better to write LM0. Yes, we are using 16 by 2 LCD. By double click on that, it comes here, then okay. Okay, at first we choose our at Mega 16. So we interface our keypad with port A. It's better to put keypad near to port A. Okay, and we interface LCD with which port?
C, port C.
Very nice, thank you. Okay. I start to have my connections because you see that there are so many connections here. I don't use wiring. I will give you a technique. I will teach you a technique without wiring to have a tidy simulation. You can use it. Here in left side, we said that there is a button which is related to terminal mode. Okay, this button. In terminal mode, we have default. By choosing that, you can connect to all of the pins that you want to have a connection with other sections here. Instead of wiring, I'm using this one. Again, port A. Okay, I want to change its direction by using rotate option. Yes, RS. I'm not using a mouse, but please, you try to use mouse, because without mouse it would be so difficult. Okay. We are using which method for interfacing LCD? 4-bit. In a 4-bit method, only we are using 4 pins of data bit of our LCD: D4, D5, D6, D7. And also they are connected to which port of our microcontroller? Port C. I also changed its direction because I want to connect to port C. Yes, port C is here. Okay. Now, my God, what is happening? Why it's not working? Okay. We said that, yes, it's working. We said that each of these rows are connected to 4 valuable bits of port A. 4 valuable bits are these bits: bit 4, bit 5, bit 6, bit 7. Okay, and we said that the columns are connected to first 4 bits: bit 0, bit 1, bit 2, bit 3. So I start to from the columns, and then the connection related to the columns, and then I will continue with the rows. This is column 1, am I right? So I call it C1, which is connected to which bit?
Bit 0.
Column 1. Very nice. I call it 0, but I use the same name for this one. Column 1, which is connected to 0. Okay, about this one. This is which column? Column 2, which is connected to first bit 1, okay? Then I will use C2, 1. This is what? Column 3, which is connected to bit 2. Then column 3, which is connected to bit 2. And column 4, which is connected to, column 4, which is connected to bit 3. The same name is used for that. So then here, this is first row, row 1, R1, which is connected to which bit?
4.
Very nice. Thank you. Thank you. Again, R1, 4, R2, 5, R2, 5, R3, 6, R3, 6, R4, 7, You can use any type of name, but because I want to have by looking in the name of them, I want to have some information about their connection. I use these names. However, for example, you can use R1, R2, R3, R4 and the same name for interfacing and connecting to the our microcontroller here, R1, R2, R3, R4, or for example, C1, C2, C3, or any type, any name that you want, but the name of this one should be the same with this pin of microcontroller, because actually this action is meaning the wiring. For example, when this terminal has one name, this terminal should have the same name, because it's meaning that this pin is connected to this pin of keypad. However, if it's difficult for you, you can use your usual wiring, but it makes your simulation so complicated when you're using more than one devices. For example, you're interfacing keypad and LCD, or sometimes there are other devices which are interfaced with your microcontroller. So here, RAS, RWE, and D4567 are connected as this code that's generated. RAS is connected to bit 0, RDEN are connected respectively with bit 1 and 2. Now, I call it 1, 2, 3. Then we said that RAS is connected to bit 1, 2, 3. Then D4, 5, 6, 7 are connected bit 4, 5, 6, 7. Because I started from 1, then this one would be equal 8, 7, 6, 5, then 8, 7, 6, 5. And you see that one of the bit 3, this is bit 3, 0, 1, 2, bit 3 is no connected. It's not connected to any pins of LCD. Then we can erase it. Okay. Now our connections setting is okay. And I want to go to my codes. I said that at first step, we should do what? We should scan the key of keypad. At first, I said bit 0. Bit 0 is related to which column? Column 1. Bit 0 is related to column 1. 2, 0. Now, I want microcontroller to read each of these rows. This row is connected to bit 4, bit 5, bit 6, bit 7. Okay? Good, listen to me. I make this column 0 by using this code. Then I want microcontroller to start the reading the rows. Rows are connected to bit 4, bit 5, bit 6, and bit 7 of port A. I want to read it. If pin A bit 4 equals 0, return 7. If pin A bit 5 equals 0, return what? Return 4. If pin A bit 6 equals 0, return 1. This is unsigned. I want to use this key for clearing my LCD, okay? Because in my keypad only I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. I don't have 10. For this key, I use 10 number, okay? So again, port A 0xFD. What does it mean? It means that this column is 0. Then read the value of these rows or these bits. Again, if pin A4 equals 0, then return what? I'm talking about this column. Return 8. Read this one. If pin A5 equals 0, return 5. If pin A bit 6 equals 0, return 2. And if pin A bit 7 equals 0, return 0. Again about this one. And for equal sign, I used 11. You see that. About the other step that I'm making column 3 equals 0, this code, okay? You see that for pin A bit 7, which is related to this key, which is equal key, I used 11 number because we don't have 11 here. You can use any other number, for example, 22, 20, 80, 100, 200, 400, any number which is not existing in your keypad. So in next step, I make last row equal 0, this code. And then again want microcontroller to read their values. If this is 0, meaning that this key is pressed. If this is 0, this is pressed, and so on. And you see that for division sign, I used again 100. For multiple sign, 200. For minus sign, 300. For positive sign, 400. You can use any other number, but you should careful to use them in next step when you want LCD to print it and print the key in LCD screen. So let's go to write the other section of our code. Okay. This is again a user-defined function, void LCD int key. Yes. Hi, Khaled. I'm in class. Okay, thank you. As previous one, that was user-defined function, I again define a function as this one for printing the keys numbers on LCD. If key is equal 1, LCD puts 1. If key is equal to LCD puts F2, and for example, if key is equal 100, we determined 100 for what? Do you remember? We determined 100 for what? For division sign. Then we said that when this column equals 0, read the value of each of the rows. And if bit 4 equals 0, then return 100. If the value of bit 5 equals 0, then return 200, 300, and 400. Now I want to LCD to put safe the value related to each of the keys and the sign of them when these values are returned. If key 1 puts F1, if key 2 puts F2, you see that I used return 7 for 1 for these three numbers, and for for this sign unsign I used 10 number. You should be so careful about using the number that aren't the key numbers, meaning that they are related to the signs. For example, when it's returning 100, it means that the LCD should print which value? Not value, this sign, meaning that division sign. So you see that if key is equal 100, LCD puts F division sign, but division sign should be inside double quotations and inside the parentheses. If key equal 200, puts F multiple sign. You see that I wrote it here. If key is equal 300, puts F minus sign. You see that. And if key is equal 400, puts F positive sign. Moreover, I want to, as I said, I want to use this sign or unsigned for clearing NCD. And I called it as which number? Do you remember?
10.
Very nice, yes. And I want to say to microcontroller, if key equal 10, LCD underline clear. Meaning that when I push this key, my LCD will be erased. So this is my code. I started to scan my keyboard. I wanted to LCD by using these if statements, print the values of a keyboard on LCD, but we need to merge these two user-defined functions. But before that, we know that for each of the variables and each of the user-defined functions that we use them in our codes, at first we should do what? We should declare them. Am I right? So I use these two user-defined function at first before main function for declaring them, because if we don't declare them, we have error. This is another user-defined function. Again, I declared it. Okay. Now, we have two user-defined function. We need to merge them with each other. As you see here, I use the code do key is equal keypad, key equal underline pad is user-defined function for what? This is user-defined function. For what? For printing keypad. Am I right? Now,
Yeah.
I want my microcontroller, after doing this function, meaning that after printing my keypad's keys, puts the data inside key, okay, and then I want to LCD, put it inside LCD, meaning that I'm merging these two user-defined function. One of them is int key underline path, and the other one is void LCD. Then I want to print my keypad and put it inside key, and then LCD key, meaning that merge these two ones, print it and scan it, and then put it, print it in LCD. Moreover, as you see here, I'm using delay. Why? Because if we don't use this delay, by pressing one key, then the key is shown in LCD 100 times, infinite times. And for showing only one time, I creating, for example, 200 millisecond or 300 millisecond delay. Moreover, you see that when a key is pressed, okay, then print it an LCD. When no key is pressed, do nothing. I want my microcontroller. When a key pressed, put it inside key and print it an LCD. When no key is pressed, do nothing. Do we have key 12?
Yeah, that's I'm
Do we
asking
have?
about, hocam. There is no key 12.
Yes. Nas, what?
There is no key 12. It's not defined.
Yes, very nice. We don't have key 12. Then what does it mean? When we are asking a microcontroller, do nothing, meaning that press key 12, because we didn't determine here key 12, then microcontroller do nothing. Okay, for example, instead of 12, you can use 1000. Any other number which is not using here, okay?
Nice.
When you're using a number which is not used here for scanning or printing, then it means that our microcontroller, please do nothing. So again, I add this code inside my while function or while infinite unconditional statement. Where is while? It is here. Yes. Okay, but you see that here we used a variable again to put all scanned function material inside key to print it an LCD, okay? Then we need to do what? For when we are using a variable, at first we should do what? Key is variable here. We should do what? We should do initialize or declare it. Then I come to my codes again and I declare it as a global variable. Int key semicolon. So our program needs what? Do you know? We merged two functions, two user-defined functions. One of them is return function. The return values are integer number. The other is void function, and it is not returning anything, as you see, only executing something, printing something on LCD. But as you see, inside while we are using delay function. To do that, we need to add what in our microcontroller? Help me. In our code, we should add what? We should add the preprocessor related to delay function. Am I right? So I run my program and we don't have any error. Please open your microphone because I don't want to come back to our chats. If you have any question or you want to say something to cooperate with class, please open your microphone and talk in the microphone. So then we need to convert our data to our microcontroller. In desktop, I used project key. Because I had problem in creating files inside the code, I make mistakes and put the codes inside pro. Then okay, let's to run it. I hope that it works. Okay, you see that 7, 8, 9. Okay, 4, 5, 6, 1, 2, 3. Division, multiply, minus, positive, equal, 0. I want to clear my LCD. Unsign. Again.
Hocam, it's not working as calculator.
No. No, it's different. We are talking about keypad. The calculator is a different situation, and only it's working as keypad. To do that, we should have another situation, and it's not related to our codings in AVR, or it is a completely different section, and actually it should be coded in MATLAB. For having calculator, we should code in MATLAB and so on. So suppose here we are deleting this delay. We want to consider what happened. Again, execute it. Okay. What happened? When we are pressing one of the keys, because there aren't any delay for stopping the connection between that row and column, it's trying to show it infinite times. But by creating delay, actually we create situation to show only one time each of the keys. Any questions?
Hocam, could we able to make it working as calculator?
I said that it is out of our syllabus, and it's better to work, if you want to work with calculator, it's better to code in MATLAB.
Oh, it would be more complicated?
Yes, of course. This is only related to the keypad. It is a completely different. It is mathematical calculations, and it should be done in MATLAB coding, and it is so difficult. When, for example, you want to have a calculator for calculating an integral, I don't know, radical and something like this, you should have so many calculations and you should write different codes in MATLAB, long codes in MATLAB.
Nice.
Okay.
Thank you.
Any question here? Then what we did, at first we chose our microcontroller in CodeWizard. We enabled LCD. Because we are using delay, we used preprocessor related to delay header file. Because in our codes, we are using two functions. One of them is void function, which is used for printing the keys values on LCD. And the other is return type, and the value which is returned is integer number. We should declare them at first of our codes. One of them is related to scanning LCD, and the other to printing, scanning keypad. The other one is printing the value on LCD. So we should add before our main function and add it at first of our coding. Then we said that because we are using a variable, we should have it's declaring as global or local variable. I use the global variable int key. Don't forget the semicolons. So we said that at first we had some choices, some selection in port section of CodeWizard. We said that instead of this code, we can use what? 0x, I forget it, 0x 0f. Am I right? And instead of this one, we can use 0 x 0 no ff. So again, if we don't use CodeWizard option for initializing one port pins as input or output, or as its initial state or pull-up resistor activation in CodeWizard, we can use these two codes instead of that. I want to see that. Is it working or not? Yes, the same values. So we said that in initializing LCD, it's better to not delete these connections because we are using them in our simulation and experimental in laboratory. This is initializing of LCD, which is done in enabling LCD in in CodeWizard. Then inside while one function, we merged two user-defined function, which was one of them is related to scanning of keypad, and the other one is printing of the scanned values in LCD. And we wanted our microcontroller to do nothing when no key is pressed, and to do that I use the key which is not existing in my key numbers in scanning values. For example, you can change it to, for example, any number that you desire, 50, for example. Again, I want to go my codes. What happened? Yes, you see that it's working. Any number that you desire and you're not using in scanning of your keypad, you can use here. We created delay and I explained why we are using delay. So we use this section related to while one section to merging keypad and LCD function with each other. And I explain about each of these user-defined functions and so on. If you don't have any question, we can finish our class. About final exam, I want to say that it would be face-to-face. And I want you, maybe want you to write a code on the sheet. Unfortunately, we don't have any opportunity to have laboratory for giving you PCs because the number of the students are so high for having the simulations in Proteus and writing the codes in CodeVision. However, in previous semesters, we used this strategy for our exam, but unfortunately, this semester I can't do it. Then I want you to write a code in the sheets, your exam sheets. Also, maybe we will have some questions related to first chapters. As our midterm exam, it can be multiple choice or it can be experimentary. I think today is our last session, and if you have any question, I'm here to answer you. Don't hesitate, ask your question. If you don't have any question, we can finish our class.
Thank you so much.
Thank you, thank you, thank you very much for your cooperation. Some of these students are really trying to learn something, and I'm really thankful, appreciate you. Okay, thank you very much and have a nice time. See you, bye bye.
Ojam,
Yes,
excuse me. Are we having exam face to face or online?
exactly 2 minutes ago I said that it would be
But you say
face to face.
it's face to face, but you're not so sure.
No, I'm really sure it would be face to face.
Okay, thank you very much.
Okay, thank you very much. Have a nice time. See you soon. Bye bye.